My name is Jason Mays. I work for Google, based in London, and I work in a team called Innovation Services. And we work with Google's largest clients across Europe in advertising, specifically rich media advertising. I've been there for around 2 years now. Prior to Google, I was running my own company, a web development company, based over in Bristol. And before that, I worked for a semiconductor startup, picking up their web and digital online. So basically, today we're going to look at HTML5 for innovation, and this is going to cover a number of topics here. So just to get an idea of what level everyone is at, if you consider yourself really advanced, you can write a book on the subject, please raise your hands. A couple of people, good, good. So you're going to find that the middle to end more interesting, I think. Is people intermediate in the middle somewhere? Okay, and totally beginner to JavaScript and HTML5. A few of those as well. Okay, good stuff. So everyone should hopefully learn something from this. So just to cover the basics, when I talk about HTML5, I'm referring to the collective HTML, CSS, and JavaScript. And as we know, CSS is for styling, HTML is called the semantic markup, and JavaScript is for the behavior and the logic. And there's some interesting websites scattered throughout this presentation. I'm going to give the link to this presentation at the end of the day. So don't worry about taking notes, you can get all of this online. This presentation is actually written in HTML5 as well, which is awesome, so it's cool. So moving on, so what are people currently making? Just some examples to get us interested right now. So there's something called 100,000 stars, which uses WebGL, CSS 3D, and web audio, and basically it's a 3D simulation of like literally 100,000 stars in our universe. And you can zoom in to these stars and get data from various databases and read information about those stars, which is very, very cool. I would demo it right now, but unfortunately the site is down. So maybe when you check it later on, it will be back up again. The second thing is HTML5 drum kit. Now this is using web audio once again, and it just shows how you can get precise timings with multiple sound sources occurring at the same time. So I've made a little demo here using that, and hopefully you can hear this. Let's try this. So every sound is being played at exactly the right time. It's quite simple, and you might think, why would I want to use that? But having that precise control is very, very useful, as we'll see later on. Okay, and if you add a bit more beauty to this with CSS and styling, you can make something like Jam with Chrome. This also uses WebSockets to connect people in a multiplayer capacity, which is very, very cool. So if I enter this right now, and pick an instrument, hopefully below. Okay, let's go on the drums. This is all HTML5. No Flash is used anywhere in this presentation. And if someone else then joined, if I invited a friend, they can then join with a different instrument and we can all play together in the same virtual sound room, which is really quite cool. And it can be recorded and so on and so forth. So I encourage you to look at that in your own time. Next thing is block-based destruction of a HTML5 video. The best way to show you this is just to literally show you. So here's an HTML5 video, and it's playing, and I can click on any part of this and blow it up. And note how each individual segment is still rendering its portion of the video, which is very, very cool. And it's totally fluid as well. So give it one more time, just blow it up like so. So this is using the canvas element, I believe, combined with the video element, which allows that pixel level manipulation. So my key point here is that from simple things come great things. And taking the video again, this is just a HTML5 video like before, and we can start rotating it around the x-axis, the y-axis, and the z-axis. Okay, so nothing too fancy there. But why is that even useful? If we add some CSS and styling and combine it with, say, the Flickr API, we can then bring photos in from Flickr, like so, and make a really cool immersive 3D gallery, which is very, very nice. And notice how smooth this is. It's a little bit laggy on the projector, but on my screen it's pretty smooth. And no matter how many you bring in, it just flawlessly executes. And this is what we should be striving for in our applications, things that are beautiful and work really, really well on all browsers. So, moving on. Today we're going to concentrate on geolocation. Has anyone used geolocation yet? A few hands, good stuff. So, for those of you who haven't, why might you want to use geolocation? Well, there's a few scenarios here. The first one is when you want to assist the end user, your client. So, where is their nearest bus stop or their nearest shop, and so on and so forth. The second reason is for efficiency. So, if you are an owner of a taxi service, then maybe you want to send a taxi to someone who's already nearby to you to save on petrol costs. You can also use it for estimation and prediction, for shipping costs if you're an online shop. If you know someone's based in the UK, maybe you know that you want to send them international deliveries, so you can update the price accordingly. More recently, augmented reality in the gaming industry has become more popular as well. So some of you may have heard of Google Ingress, which is basically a game you can play walking around the street using your GPS location to hack portals and do crazy things like this, which is very immersive and very, very fun. Finally, for relevancy, so contextually available news. So if you're in Odessa, then you're going to want to know different things than someone in Kiev, for example. Cool. So what are the advantages and disadvantages? So if we've got GPS available, so if we're on a mobile device, then this is really great because you can get really, really precise positioning down to a couple of meters, potentially. If you're based on a desktop PC, you can still use some form of IP address geolocation. So it's going to take the IP address of the computer and look up in a big database and get a rough approximation of the city level, usually at least. Once again, if you're on mobile, you can have real-time polling of the location. So this means as the user moves around, their location will be updated in real time and sent to you, so you can change your content accordingly. And finally, if GPS is supported, you can get extra information such as the speed they're going at, their compass heading, and also their altitude, which might be useful for your application as well. So, okay, what are the disadvantages? Well, basically, it can take time to get a GPS fix, but if you don't need GPS and you just want to get a quick lookup, you can disable that and just ask for a general location. And finally, it requires permission by the user in order to use HTML5 geolocation. So there's a pop-up on the web browser saying, do you want to allow access to your location, and the user has to say yes. The good thing about this is that the preference can be remembered for next time. So once they've done that, your site is then approved, if you will, and they don't have to do that again and again. Cool. So today we're going to build a robust geolocation component, and we're going to do that by using the module design pattern in JavaScript. Has anyone used the module design pattern? One hand, two hands, okay, three hands, good. Okay, so most of you are going to be new to it, but don't worry, we'll go through it in detail. And we're also, of course, going to touch on a W3C geolocation API, which is, of course, how we're going to access the user's location. And there's no reason not to really be using this in your applications. It's supported by even Internet Explorer version 9+, which is great, and a wide variety of other browsers, both on mobile and desktop devices. So as long as they're using the latest browser that they like, it's probably going to support geolocation. So, the module design pattern. Now, my colleague at work quotes it like this. I'll just read this out to you. The module pattern provides a way of wrapping a mix of public and private methods and variables, protecting pieces from leaking into the global scope, accidentally colliding with another developer's interface. Now, what on earth does he mean by that? That's quite a lot of words there. Basically, all he's trying to say here is by implementing this design pattern, you're going to reduce conflict of variable names and function names with your existing code. So you're not going to overwrite your code. JavaScript loves to overwrite itself if given the chance. So we're only exposing what we need to via a public interface, and all the rest of it we're going to keep private, so people can't even call those functions. It's separated. And that's very, very powerful. So here is the module design pattern in its raw form. I'm just going to walk you through this. So what we're doing here is declaring a variable, and here we're going to call it unique component name in this case, and we're assigning to this a function, and this is just an anonymous function, so it's not got any name associated with it as such. Now, when you write code inside of the function, these variables are going to be private. So here is just a regular private variable, and this function is limited to within this, this component we're going to make. So if I try to access this from outside of this component, it would give you an error saying it didn't exist. Oh, it's okay. I like pointing, but thank you. So how on earth do we expose public properties? Well, if we scroll down here, we can actually just simply use the return statement of the function to return an object into the squiggly brackets here. And in this object we have a property, and we assign to this a function. So here's an example of a public function, and here's another function. So that's how you return the object back and assign it to the variable. So when your JavaScript is loaded, you need to somehow execute this straight away, so this gets assigned to the variable above. And the way we do this is this tiny bit of code at the end of this declaration. And this means it's self-executing. So when JavaScript is downloaded to the page, it's going to execute this function. The return statement is going to be called straight away. And that object that we've created there will be assigned to this variable here, which then allows you to go unique component name dot a public function to then access that property. Okay, does everyone follow what's going on here, or am I not clear? There's a few nods. Good. Okay. So it's a very useful pattern to know. So let's start actually making stuff. So first of all, I'm just going to rename it to Geocoding to make it more interesting. And then we're going to define a private function to check if geolocation is supported. So all we're doing here is checking for the presence of geolocation within the browser we're in. And we're going to return true if it does have this, otherwise return false. Very simple, nothing too fancy. And just to emphasize where this is going, this is supported function. It's basically, I'm just going to paste it over this part here. Okay, that's all I'm doing. Perfect. So next, we're going to expose a public function to actually allow us to perform the geolocation. And this is going to take one parameter, which is a callback function. So all we do here is we assign this to a private variable, so we can store this and use it later on in our code. And then we simply check if geolocation is supported by a browser. And if that, remember, returns true, we're then going to call the W3C API. Okay? And in order to do this, we simply go navigator.geolocation.get current position. So this is actually part of the geolocation API, okay, in HTML5. And this takes two parameters. One is a function to call upon a successful geolocation, and one is one you have to call when there's an error. Okay? So let's go ahead and define those two functions now. So in the case of a success, it will return you a position object. And we're simply going to pass that back to the callback function that we stored earlier on. Okay, that's why we stored it earlier on, so we can now call it at this stage. And if there was an error, it returns you an error object. And if the error code is equal to 1, it means the user denied access to the location. They said, no, I don't want to be found, and the browser doesn't give you their location. If it's error code number 2, it means no position could be found for some reason. Maybe an IP address couldn't be found with an associated location, or maybe a GPS failed, or something like this. Otherwise, the request simply timed out. So these are the 3 error states you need to handle in your application. So, if we jump into the JS Fiddle, which is a great online tool to kind of test JavaScript, CSS, and all. What's going on there? Interesting.
No, I think it's not connected.
The Wi-Fi's gone.
Yeah.
Which Wi-Fi would be? He's got internet access now. Oh, it's actually connected.
No, that was at work.
Oh, I see.
It's an office. They're all up here.
Okay. There we go. Okay, that's okay. So JS Fiddle is an awesome tool when it works. And basically, all we've got here is one part to put your HTML in, one part for your CSS, and one part for your JavaScript. And I've simply filled this JavaScript out with all the stuff we've just been talking about. So this is the module design pattern filled with our geolocation components. So, if we scroll down, oh yes, so this is what I was talking about earlier. So when it tries to access your location, at the top, the user has to click allow, okay? So I'm going to go ahead and do that right now. Hopefully it's timed out. And as you can see, it's now found our longitude and latitude, and it says it's confident within 30 meters it knows where I am right now, okay? So that's pretty good accuracy for something that doesn't have GPS attached. We're just using our well, maybe the Wi-Fi might be using this, or for IP locations. So that's pretty cool. And if we did have GPS available, we could have the altitude, the heading, and the speed as well, which could be useful for your application. So that's all very nice, but we can do better than that. So what we want to do now is support higher accuracy results. So we want to force the device to use its GPS. And also we want to specify a minimum time for staleness of the results. So maybe you want to have something which is really, really fresh and accurate within the last 5 seconds, but maybe you're not so bothered either. So if you're happy to have a cached result for the last hour, then maybe it'll come to you faster, so we can do that as well. So let's go ahead and add that to our function. So here's our geolocate function from before. Remember, it's just one parameter before. We're now going to add 2 more parameters, maximum age and high accuracy. And first of all, we just check if maximum age is undefined. And if it is undefined, we're going to give it a default value of 1 hour. Okay, so we've been interested in things up to 1 hour ago. And similarly with high accuracy, if that's undefined, we're going to set that to false. And the reason I set that to false is that if you're going to force high accuracy on a mobile device, it means it's going to use the battery power a lot more, because it's going to use the GPS. So in the default case, unless you really need the high accuracy results, then don't use it. If you're happy with just a general location to get city level accuracy, then just don't need to enable that to save battery power, which is very useful for mobile devices. And then just as before, we call our get current position in the HTML5 geolocation, but it takes a third parameter this time. This third parameter is an object, and it has two properties, which is simply our maximum age and our high accuracy value here. And you just pass that through, and it will work out of the box. Any questions on that? Don't be shy. I don't mind questions. It's all good. Okay. So the next thing, we want to add real-time updating ability to our components. So this is where, if the user is moving around on a mobile device, we can be alerted when their location changes and then update our view on the map or whatever it might be automatically, which is very, very powerful. And there's a way to do this, which is very simple, which I'll walk through just right now. So I add an optional fourth parameter, continuous, and we simply check if continuous is not undefined and it is true. So in this case, we're going to call watch position instead of get current position. And it takes exactly the same parameters, but the only difference is watch position will keep calling your callback function every time the user moves. And the important thing to note here is that you can't specify when to update the position. The mobile device will tell you when the position is updated. So we've now got a very robust geolocation component that allows you to specify to use a GPS and get longitudes and latitudes and so on and so forth, which is great, but it's not very useful on its own. It's got a bunch of text. So typically we need to integrate with third-party data and APIs such as Google Maps to make it more visually meaningful. Oh, sorry, yes?
How frequent mobile device can report your location?
It depends on how fast the user is moving and down to the device as well, its manufacturer. So it will determine the update interval. You have no control over that. It could be 1 second, it could be 5 minutes. When it thinks they've moved enough to warrant an update, it will alert you to this.
Can it be less than 1 second?
Potentially. I've never experienced using it that fast, but if I was moving at such a speed that it warranted an update, then potentially it could do so, yes. 1 second, there's one guy over here. You answered? Okay, over there.
I have one question.
Is it possible to control this frequency?
No, the mobile device will determine this for you, depending on the way it's been implemented.
But it will drain the battery.
But this is the reason it's implemented like this, so it saves the battery power if it can. Yeah. Yes?
Can we specify some kind of minimal distance? So, I mean, if user position is changed for 1 kilometer, then we will call back.
No, it will call you when it feels like it. You have zero control on this one. Okay?
May it depend on user speed?
Sorry?
May it depend on user's speed?
I said speed because the usual way to determine when to update you is when it feels it's changed enough. So if they've gone very far, then it's probably a good idea to update you that the location has changed. So I presume if you're going faster, it will give you a faster update holding time because of that reason. You're traveling that distance first. Yes. Good question. So I'm going to get that. 1 second. Basically, sorry. So in the watch position function here, notice that I've assigned the result of this to a variable, okay? And you can use that to then stop it later on, okay?
So it's the same as the set interval window function.
Sorry?
We have that set interval window function, which returns the ID of the interval window.
Okay.
So it's working the same.
So yes, it's not like set interval because in that you're specifying a time in milliseconds at the end, right? So basically you're specifying no time at the end. It's just going to call you back whenever it wants. Okay, so that's a key difference there.
Is this the main concept of assigning like callback to this set interval?
Oh, I see.
This
Okay,
set interval.
yes, like this you can cancel it in the same fashion, correct? Cool. So that leads us on to remote data access and APIs, which is a riveting subject. So first of all, what on earth is an API? Once again, a nice quote here. An application programming interface, or an API, is simply a protocol intended to be used as an interface by software components to communicate with each other. So more simply, basically, think of it as a black box, okay? And this black box, you can give it some inputs. And when you give it certain inputs, you get some outputs, okay? And how it does that is not exposed to you. It's all hidden away. But it's basically, there's thousands available, and such as ones from Google, and you can use these to enhance your applications, such as Google Maps and so on and so forth. So we're going to extend our component to use the Google Maps API, so we can actually get a visual representation of our current location. And in order to do this, we have to include the Google Maps API. So we just have a script include in the head of our page, or maybe at the bottom if you prefer. We're going to add a div to our HTML so we can render the map into this later on. And it's important to set a width and height for this element. If you don't set a width and height, the map will be blank because it doesn't know how big its container is. So always set a width and height in the containing element. Just going to take a drink. Okay, so we're going to write a function called generateMap. This is a public function, and it takes a few properties here. So the first one is the HTML element ID that we want to render the map into. So this allows us to reuse the function for other elements if we want to. We're going to pass it a longitude and a latitude. And of course, we're going to set the zoom level and the map type. And the zoom level is simply how zoomed into the map we're going to be, so right down into the road level or the big global view. And the map type is like the satellite, the terrain, or the road map that Google offers. Okay? So first of all, we do a bit of checking as before. So we check if zoom level is undefined. If it is undefined, we're going to set it to 14, which is fairly zoomed in. You can see all the roads and stuff. So that's quite nice. And we've set it to roadmap by default as well, if that's been undefined. We then have an object created here, which has 3 properties. The first one is the center, and this is simply an object of google.maps.lat_long, which is simply a latitude and longitude pair. Okay, we just pass our latitude and longitude from above into this, and assign it to center. We then pass through our zoom level and map type, and we've then got an object we can use with Google Maps. Okay, and then this line is where the magic happens. So here we're going to create a new instance of a Google map. So new google.maps.map, and here we're going to take the ID of the element we want to render it into, and we're going to get a reference to that element using the standard JavaScript get element by ID, and we're then going to also pass our map options, which we define here, as a second parameter. And when that line executes, the map will be rendered onto your page. Okay? And I've assigned the result of this to a variable because if you want to manipulate that map later on, you'll need a reference to this. And here, for example, you can add markers to show nice little kind of your position and title text and so on and so forth to make it more interactive. So let's go and try that, and hopefully you guys can tell me if it's actually correct. Okay, so back to the JS fiddles. And is that where we are? Can anyone verify that? Yeah? Okay, good stuff. So that's worked, and it's much more visually appealing than the dungeon text we had before. Yes, questions?
Is there any difference that as developers should be aware of between regular HTML5 maps and the GL maps that Google supports?
Well, I'm using the Google Maps API to do this, so I've not experimented with the HTML5 maps you're talking about.
I mean, this is regular maps that use HTML5,
I see.
CSS, and JavaScript in the background, and there is a component that you can download in Chrome.
Okay.
To use to render maps.
This is using the regular HTML5 stuff. Yeah. Yeah. So that's worked successfully, which is really good. The next thing I'm going to do is add support for reverse geocoding. Now this is not as scary as it sounds. All this means is that given a latitude and longitude, I can find the street address, or the best guess of the street address for that longitude and latitude. So that makes it more useful to us if we know, like, oh, we're in Odessa, or we're in Ukraine, or wherever it might be. This is much more useful than the longitude and latitude. So we can do that quite simply by, well, first of all, I'm going to add a private variable called geocoder, and I'll show you why in just a second. We're going to create a new public function called reverse geolocate. It's going to take a longitude and a latitude and a callback function. Okay? And just like before, we get a new position variable, which is a google.maps.lat_long, and we're just passing it a latitude and a longitude, just like before. And then this is the important bit. Now, if geocoder is equal to null, we're going to create a new instance of google.maps.geocoder. Okay? And the reason we do that is if we're going to call this function like 1,000 times, we don't want to be creating a new instance of geocoder every single time. That's a waste of memory and time as well. So we store that and cache that locally in our private variable, so we don't do that every single time. We then call geocoder.geocode, which is a function available within the Google Maps API, and we pass it an object which contains our longitude and latitude, and then we also pass it a function to call, which is called when it's successfully found our location. And this function takes 2 parameters. It will give you the results and the status object. And if we go into this, we'll see if the status was literally OK, so geocoder status.OK, then we're going to call our callback function we passed with the results. Okay? Does everyone understand how that piece of code is working? Yeah, good stuff. So let's go and try that out. 1 second. Otherwise, we return false. So if I open this up and go to our console, you'll see that it's returned an array here. And inside this array, there's 7 objects. If we go into the first one, we'll see we've got an approximation of our street address, like so. Is that correct? Good stuff.
Yeah.
Okay, and then if we go into the address components, we can also get each part individually, so the 46, the street name, I believe that is, and so on and so forth. And the one I'm really interested in is number 3, which is Odessa. So we're going to do something interesting about it in just a second. Yes?
How I can set up a language of response?
I believe it's in English only, I think, at the moment.
I tried to use this one in my project, and I got a response in Russian.
You did get it in Russian? Oh,
Yes. With English localization on English localization browser and English localization for Windows. And I got a Russian response.
Google knows everything about you.
I guess it was forced.
It is based on the API because Geocoding is located in US, and when you try it from your computer, you get in Russian because you are not in US.
Based on IP address?
Yes, IP address is in Russian.
But this one's come through in English. So,
Yes, and Geocoding is not in Ukraine.
well, yes, I know this, yeah, but our machine here is. We're making a request from this machine.
Yeah, but those are right.
It is based on localization, but it's not based on the language of the system.
Yeah.
It is based on the time settings and date format, like money format.
I'm not too sure on the answer to this one, I'd have to look it up, but if we look at the API document, there might be an option to force a language. Have you looked at that, or have you ever looked at the document?
Yes, language
In the
is
documentation,
supported.
There may be an option to do that.
You can specify the language for the results when you
Calling
use
the API. Okay, yeah.
API.
Cool. So yeah, there is an option to pass through a language. So, going back to the presentation a second. So, any other questions on that? I can always look back. Thank you. Okay, cool. So we managed to get a reverse geocode working. But in order to do that, we've spoken to the Google servers, and then they've given us some information back. And that Google server is on a simply separate domain to our website, for example. And it's actually not as trivial as you might think to get data back from a website that's not on the same domain as your website. So let's look into how to transport data from different domains. First of all, how do we store data? Now, there's a couple of options. One option is XML. That stands for Extensible Markup Language. And here's a quote again. XML is a software and hardware independent tool for carrying information. All XML tags are defined by the programmer. Okay? And the key points to note here is that XML was designed to transport and store data. XML on its own does not do anything. It's just a bunch of text, literally. And you've got to define your own tags and know how to interpret them afterwards in order to use it again later. And it's worth noting that HTML is actually a cousin to XML, so you can see a very similar syntax. However, XML is quite bloated for things we want to do in this presentation. So we should have a quick look at XML. So this is some XML, and you can read it almost like you would a book. So we've got some car dealers. One dealer is called Bob's Cars. He's got a telephone number, a website, and a location. And he's got one car with an ID of number 1, which is an Audi TT. It's grey, has 3 doors and a 2-litre engine, for example. And similarly, there's another car here. So you can read it very easily. So it's a very human, readable, friendly language to use. But there's another one, JSON, which is JavaScript object notation. And once again, the quote, JSON is a lightweight data interchange format. It's derived from the JavaScript programming language to represent data structures. Now, even though it's derived from JavaScript, you can actually use it in almost every programming language out there. There's parsers for it, so don't worry about that. But it's much simpler than XML, which is great. And because it is actually JavaScript, we can use this to our advantage and simply assign things that are returned to it to a JavaScript variable and access it straight away, which is very, very cool. So there's no parsing involved that we do have to do for XML. Okay. So here's the same example written in JSON, and it's basically a bunch of objects and arrays. So here's an object with a property of car dealers. It contains an array, and that array has actually got objects contained within it. And this has a property of dealer, and it's got a name, a telephone, a website, a location, and then there's a cards property, which is an array, and object number 1 has these properties, object number 2 has those properties. Okay, so it's a little bit more complex to understand initially, but once you get used to it, it's quite simple to read. And it's a great tool online called JSON Lift. So if I copy this and open it up, this is a great way to check if your JSON is correct. So if it is, it goes green like so. If I make a horrible error, like so, it goes red and it tells you where the error is. This is a great way if you're new to JSON to kind of help debug your code. Okay. So why are we using Ajax? I mean, I'm sure some of you have heard of Ajax before. Now, yes? Oh, our hands are going up already. Good stuff. Okay. So everyone knows Ajax. That's great. But the problem with this is that Ajax, traditionally at least, was constrained by the same origin security policy, big scary words. Basically, this means that if you're not on the same domain name and you're trying to use this, it's going to fail. It won't allow you to access that data, which is not good. That's the code for it. I'm not going to go into that right now because we're not going to use this, but that's the code snippet to perform an Ajax request if you so wish to do so. So how do we get around this problem? Well, very good. I'm going to go to JSONP first though. So there's one option called JSONP, which is simply JSON with padding. And it's quite cheeky in how it does this. It uses the property of the script tag HTML element in order to achieve what it needs to do. So step 1, using JavaScript, we actually programmatically create a script element. Okay. We then set its source attribute to be the remote URL that we want to get data from. Okay, so this is like somewebsite.com/search equals cats if you wanted to search for cats, for example. Okay. Now, when the script tag is loaded into the web page, added to the web page, the content is going to be loaded automatically because this is how script tags work. And if that content that is loaded is actually a function call to a function we know that exists and is public in our code, we can pass a JSON object to that function, okay? And then we can have access to that data that has been returned to us. Does everyone understand how that's kind of working? A few nods. If you don't understand, feel free to shout out, it's fine. Okay. I assume you will understand the next few slides at least if you are unsure. Okay, good. So let's see how we can use this. We're going to use the Google Plus API. Does anyone know about Google Plus? Okay, good. Oh yes, I'm wearing a Google Plus t-shirt. So basically, we're going to actually search for real-time posts about Odessa using our geolocation components from the Google Plus API, using JSONP to bring that data back to us and then print it out into our web application. Okay. So there's a few things we need to do here. First of all, we need to generate an API key for Google Plus. We're going to take a quick look at the API to see how to use it, and then we're going to create one of these magical JSONP requests to grab the data, and we can handle the response and print it out. Okay. So, when I've given this presentation before, people actually have all their laptops with them, they're following along and everything. I know not everyone has a laptop here, so I'm just going to skip over the slide. This is just the instructions how to generate an API key. And if you go to these URLs, you can generate one for yourself, for your own project as well. And these slides will be available after the presentation if you want to go through them on your own time. So the actual search API. Basically, I've done the hard work for you. I've gone through the documentation and picked out these parts here, which is what we need to be interested in. First of all, in order to use the Google Plus API, we must make all of our requests to this URL. Okay, so everything will start with this part of the URL. There's one required parameter, which is the query. So if we're searching for cats, the query would equal cats. Okay. We then can specify a callback function. So this is the public function we're going to call to allow us to retrieve data back from the server, which is in our own code. Okay. There's a fields parameter that allows us to say, I only want to take certain data from the post on Google+. If you ask for everything, there's like the author, their picture, the URL of the post, the attachment, the content. They want all of that intent. So this allows you to get granular in what you want returned to just the text of the post, for example. And finally, our API key is also appended to the end in order to make the request. Otherwise, you get an access denied error. Any questions on that? Okay. Sorry? Okay. Okay. So at the top here, I've simply created a very long string here showing you in bold the bits we're going to need to inject into this when we make a request. So the first bit is the query, which is going to be changing depending where we are in the world. So Odessa, for example. And then this is where I'm going to put my API key, and this is going to be where I put the name function I'm going to call back. So let's go ahead and add the start component. First of all, we're going to add a private variable to store our API key so we can use it in future requests. And we're also going to add a private function which allows us to load JavaScript into the page using JavaScript, which is quite cool. So all it does is it takes a URL as a parameter. We create a variable called node in this case, and here we create document.createElement of type script. So we're creating a script tag in JavaScript. We're setting this type to be text strict JavaScript, which is how it's usually defined. And then we're setting the source of this to be the URL that we passed to the function. And then we find the head of the document, and then we append it to the head. So that's all we're doing. We're appending a script tag to the head of the document. Okay? Any questions on that? No. Cool. So now let's define some functions to set our API key. So these are public functions, so that's very simple, just passing through the key and assigning it to a private variable. And then we've got a search Google Plus function, and this takes search and a callback name. And it's important to note here that search is just what we're searching for, so Odessa, and the callback name is not a callback function in this case. This is the name of the function we want to call. So this is just a string. This is not a function object. And then we simply build up our URL with our variables injected into it. And then we call our load JavaScript function we defined on the previous slide to then load that into the page. And we did a check if the API key was set or not. If it wasn't, we would show an error. So once we've done that, we can then go ahead and output it. So this function here, handle JSON key response. This is a public function in the global scope of all of our JavaScript. So when our script gets added to the head of the page, this can be seen and found. Okay, it can be called. And all we're doing here is it's given a JSON object as a parameter, and we're going to just iterate through that object and output it into an unordered list. So nothing too fancy. I'm just going through that and outputting it into the web page. Does that make sense? Showing on that, yeah. Good. So, bit scary, but all the code I've spoken about in the last few slides combines into this. And if we click on this,